Hey everybody, this is Nick from First Coast Math Clinic. In this video, we're going to talk about the segment addition postulate. Let's get into it. Let's start with just writing out our segment addition postulate. So we have segment AC over here, and we're going to use this figure as our segment. And our segment addition postulate basically says if we have a segment, so in this case AC, and we have a point on that segment, so in this case point B, if we have this relationship, then we can relate our larger segment here, AC, to the two smaller segments, AB and BC. And the relationship we're going to have is our larger segment, AC, is going to be equal to the sum of the two smaller segments, AB, plus BC. Let's put some values here. So let's say that AB is 7 centimeters and BC is 9 centimeters. Then our segment addition postulate will say, well, we can find this total length AC by adding up 7 centimeters plus 9 centimeters and getting 16 centimeters as our total length for AC. Now, this is an idea. This is a statement that we accept without proof. It doesn't have to be proved to us, and that's what makes it a postulate. All right. So if you want to review postulates, I made another video comparing postulates and theorems. The link to that video is coming up right now, as well as at the end of this video. All right, so let's solve a few more problems using our segment addition postulate. In this example, we have our larger segment, CE, and that's going to be equal to the sum of the two smaller segments, CD and DE. So let's write out what the segment addition postulate is going to look like for this segment. So we're going to have CE is equal to CD plus DE. And now we can substitute in our expressions, our values. We know CD is 32. CD is X. And DE is 20. So we get 32 equals X plus 20. So we can solve for X by subtracting 20. And we get 12, and our units are going to be inches. So 12 inches equals X. So our length here for CD is going to be 12 inches. So we get 12 right here. And if we want to check that, well, we know 12 plus 20 equals 32. All right, let's do another example with the segment addition postulate. Okay, so here we've got our larger segment, AC. And that's going to be equal to the sum of the two smaller segments, AB, plus BC. So let's substitute our expressions in. AC, this total length, is 26. AB is X plus 2. And BC is going to be X plus 4. So let's do our substitution. So we're going to get 26 equals X plus 2 plus X plus 4. So let's group our like terms together. So we're going to get 26 equals X plus 2 plus 4. 26 equals 2X plus 6. Let's subtract 6 and 6. We get 20 equals 2X divided by 2 and X equals 10, and our units are inches, so X is going to be 10 inches. So we found the value of X. Let's find our segments now. AB, well, we know our expression for AB is X plus 2. If X is 10, we could put that 10 in for X here. So we're going to have 10 plus 2, and we're going to get a length of 12 inches for AB. So we get 12 here. And BC is X plus 4. Well, we know that X is going to be 10. So let's put 10 in for X. So we'll have BC equals 10 plus 4. And BC equals 14. So our length here is going to be 14 inches. And put my label there. And again, if we want to check this, well, we know that the sum of AB, 12, and BC, 14, has to equal that larger segment, the whole segment, AC, which is 26 inches, and 12 plus 14 is 26, so we get 26 inches equals 26 inches, and our answer checks. So we know our length for AB, BC, and our value for x. All right, let's go on to example number 3. For example number 3, we've got our total segment here, AD, and that's going to be equal to the sum of the smaller segments, and that's going to be equal to the sum of the smaller segments, AB, BC, and CD. So let's set up our equation. AD equals AB plus BC plus CD. We know our total length for AD is this 23, so we're going to have 23 equals AB, which is x minus 6, plus BC, which is 9, plus CD, which is 2x minus 19. So now let's group our like terms together. So we're going to get 23 equals x plus 2x minus 6 plus 9 minus 19. And we're going to get 23 equals 3x. And when we simplify this, negative 6 plus 9 minus 19, we're going to get negative 16. So let's keep solving this for x. We're going to add 16. Add 16. I'll finish this over here. We're going to get 39 equals 3x divided by 3 and 3. 3's cancel out, and we get x equals 13. So our value for x is 13. Now let's find our segment lengths. In particular, let's find the length of AB. AB we know is x minus 6. Well, our value for x is 13, so let's substitute 13 in for x. So AB equals 13 minus 6, and AB equals 7. So our length for AB is 7. Now let's find the length of CD. So CD is 2x minus 19. Again, we know that x is 13, so let's substitute 13 in. We're going to get CD equals 2 times 13 minus 19. 2 times 13 is 26 minus 19, and then CD is going to be 7. So we know the length of our segments, AB, CD. Now we can check this. So we've got 7 plus 9 plus 7, and that should give us 23. And we do our math over here. 7 plus 9 plus 7 equals 23. Well, 7 plus 9 is 16. 16 plus 7 gives us 23. So we get 23 equals 23, and our answer checks. All right, let's do one more example. All right, for example number 4, we've got our larger segment, QT, here, and QT is 4x minus 29. And then we've got our smaller segments, QR, which is 13, RS, which is 6, and ST, which is 2x minus 18. So let's write out what our equation is going to look like. We should have our larger segment, QT, equals the sum of the smaller segments, QR, plus RS, plus ST. So let's do some substitution. We know QT is going to be 4x minus 29. QR is going to be 13. RS is going to be 6. And ST is going to be 2x minus 18. So we'll have 4x minus 29 equals, I'll bring the 2x up front, and then we'll have 13 plus 6 minus 18. I'll get 4x minus 29 equals 2x plus 1. The 13 plus 6 minus 18 is going to give us 1. Let's subtract 1 and subtract 1 from both sides. So we're going to get 4x minus 30 equals 2x. I'm going to finish this up here. So 4x minus 30 equals 2x. Let's subtract the 4x and 4x. We'll get negative 30, so I want to keep the sign with that 30. Negative 30 equals negative 2x. Divide by negative 2 and negative 2, and we get x equals 15 as our value for x. So now let's find two additional values. We want to find ST, and ST we know is 2x minus 18. Well, x we know is 15, so let's substitute that value in. Substitute 15 in for x. We're going to get ST equals 2 times 15 minus 18. And then st equals 30 minus 18. And st equals 12. Now there's two different ways that we could figure out this total length. Qt, I'm going to show you both ways. The first way is, well, let's take Qt. We know that's equal to 4x minus 29. We know that x value is 15, so we can do substitution. So we'll take Qt equals 4 times 15 minus 29. 4 times 15 is 60 minus 29. And we're going to get 31 for Qt. Another way we can do it, which is basically our check, we know that if we add up these segments, we're going to get this total length here. So if we add up QR, which is 13, plus 6, plus 12, we get 31 back, and that was equal to our original, the value we got here, 31. All right, so two different ways to do that. We could have substituted our value x into this expression, or just add up 13, 6, and our value 12. So this video is on the segment addition postulate. We went over what the segment addition postulate is and how to do some problem solving with it. If you want to review postulates in particular, there's a link for that video coming up right now. You can check out that video. If you like this video, remember to leave a like, comment, and subscribe. This is Nick from First Coast Math Clinic.